Okay, welcome back everyone. In this section today we're going to look at transformations. Transformations are something we've seen before. Remember, those are where you move things left, right, up, down. You dilate things, you reflect things, and it shouldn't be anything new. Okay? What is new is the way that we're going to look at this, and we're going to look at it in what's called vertex form. Okay, so vertex form right here on the board is f of x equals a times x minus h squared plus k. Alright, so that's vertex form. Now what this is going to tell us is a couple things. The h and the k represent the vertex. Okay, so the vertex of your function is hk. The a value is what tells us if there's a dilation, a reflection, any of those changes. So that's a dilation or a reflection, and it's going to lead to, a way for us to see, if this thing's getting narrower, if it's getting wider, if it's getting reflected, all of those different changes. Okay, so we want to put these things in that form, and then we want to graph them. If they're in that form, they're a little bit easier to understand, pay attention, and know what we're looking at. So that's kind of one of the reasons we're going to make sure that we understand the reasons and the processes to make this happen. Alright, so here we go. First example. It says put the equation in vertex form and then graph it. Now there's a couple different ways to do this, and I'm going to show you two ways. The first way is using the completing the square method. So I'm going to take and group these first two things together here. Okay, so I've got f of x equals parenthesis x squared plus 6x, and then my minus 5 is going to stay on the outside. Now remember, the rules for completing the square says that your a value must be 1, which it is in this case. The second step was you take half of b, so b is 6, so half of that's 3, and you square it. So 3 squared is 9, and what we did there is we added that to both sides. So we add 9 here, and we add 9 here. Okay, so we add it to both sides. Now what you really want to think of is when I add it to both sides, eventually it's going to be it's going to have to be moved back to this right-hand side. So this 9 is going to have to come back over here. But the only way I can do that is then subtract it from both sides. Okay, so now these 9s on the far left are canceled out, and I've got this negative 9 over here. So when you're going through this process, what you can think is, instead of adding it to the left side and then moving it over, I can add it inside the parentheses, and then I can subtract it on the end. Alright, so what that's now going to allow me to do is take this and put it in vertex form. So remember, when you're completing the square, you take this center portion and you factor it. Well, the way it gets factored is you have the x, and if you guys remember, it's always half of b or the square root of that number, which is 3. Okay, and that ends up getting squared, and then negative 5 and negative 9 is a negative 14, and there you are. Now if you look at this and compare it to vertex form, which is right up here, it's the exact same thing. Your a value is 1. Okay, so 1 right here, we don't have to put it, but it's there. Your h value is a negative 3. Remember, because that's a negative up there in the formula, this is a positive right here in the problem, our 3 has to be the opposite sign. And then you've got your minus 14 for your k. Now what that tells us is we have the following. Our vertex is going to be hk. Well, like we said, h is negative 3, k is negative 14. Okay, the a value is 1, which means it's not going to be reflected, it's not going to be stretched, it's not going to be any narrower, it's just going to be your standard graph. And then you go through and you graph this thing. Okay, so when I graph, I've got the point negative 3, negative 14. So 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's going to be my negative 14 down there at the bottom of the screen. Now from here I've got a couple options. Since I have the original problem, I know that my c value is negative 5, and if you guys remember, your y-intercept was 0, c, so 0, negative 5. And so I can put the point 0, negative 5 on my graph, and it's right there. The other option is to take your vertex form, so this one right here in the green, and you just substitute in a number. And you can pick any number you want. If you chose 0 and substituted that in, so the 0 would go right there, you'd have 0 plus 3 squared, which is 9. 9 minus 14 is a negative 5, and you get the exact same point. And then from this green point, which is my y-intercept, I reflect it across my axis of symmetry, and you now have your 3 points that you can draw in your parabola. So there's your first option, is to use the completing the square. If you are comfortable completing the square, it's something that you can get pretty good at and save some time with. Now the trick to that is you got to make sure you understand that your a value has to be 1. Okay, so in this case, my a value is not 1. My a value is -2. So what you're going to have to do is make it a -1 by factoring. So I'm going to factor out a -2. Now when you factor out a -2, watch your signs and make sure you pay attention to what you have. Okay, so I factored out a -2, 8 divided by that -2 left me with this -4, that's why it is what it is right there. Okay, now you take half of b, so half of -4 is -2, -2 squared is +4. Okay, so I'm going to add +4 over there, and I'm going to add a -4 over here. Now remember, we have to do the opposites. Now the trick with this is, I'm not just adding a 4 inside my parentheses. I'm adding a 4 times a -2. So it's actually going to be adding in a -8 there. And that is a very common problem. You've got to be careful with that. Okay, so when I put this -4 on the far right, I also have to multiply it by that -2, which would be out in the front. So careful on that. Now factoring this down, you get f of x equals -2. That set of parentheses there factored gives you an x minus 2 squared. And then on the far left, I've got a -3 from here. I've got the +8 from there. So combining that down gives me a +5. That is now in factored form. Okay, so we're going to take this, and now we can graph it. So to graph this thing, I set up my graph. Vertex is HK. Well, H is 2, K is 5, so vertex is 2, 5. So I go to my graph, 1, 2, 1, 2, 3, 4, 5. I've got that there. There's your vertex. Now what you should realize is two things. You've got a negative, and if you remember, a negative means it's reflected down. You've got a 2. The 2 mean that it's a stretch, so it is going to get narrower. Okay, so a couple options. We substitute in a point maybe. If I substitute in 0, I take 0 and substitute it right there. So you've got 0 minus 2 is -2. -2 squared is a +4. +4 times -2 is -8. Plus 5 is -3. And that gives me the point 0, -3, which is right down there. The other option is go back up to your original equation. And notice right there, you have a -3. And our y-intercept is 0, -3. And it works. Okay, then we take this point, we reflect it across here. So we go 2 more. There's your reflected point. And draw in your parabola. And there you go. Now, since we knew that it had to be reflected, it had to open down. That's a very good way to check your work. Okay, hopefully that made some sense. If you have questions, contact me. We will actually discuss the second way to solve these in our class discussion board. So look for that. That'll be a good discussion point. All right, if you need help, contact me. Otherwise, good luck on your assignment.